Okay, this is part 2 of our lesson on equation of a linear relation. So in part 1, we took two tables of values. We found their initial value or zero term. We calculated their rate of change, so what they were going up or down by each time. And we wrote an equation that would allow us to calculate any term that we wanted in that table. So we're going to take a look at the question 2 that says calculate the rate of change and initial value and then state the equation. So the difference between these questions and these questions is that here the initial value or the zero term was in the table, and here the initial value or zero term is not in the table. So I have a little bit more space because we're going to have to do a little bit more work to try to calculate rate of change and initial value. So let's take a look at our very first one. We have x and y, and when I look at the values on the x side in particular, I don't see a term 0. So the initial value is not given to me in my table. If it was, I would start by writing that down, but since it's not, we're actually going to start with the rate of change. So rate of change is delta y, the change in y, divided by delta x, the change in x. So what I'm going to do is start by calculating my differences on the x and y sides. Sorry, I paused because I think my computer froze. All right. So from 6 to 10, I went up 4. From 10 to 14, I went up 4. And from 14 to 18, I went up 4. So that's a good start. We're going up by the same amount, which makes me think this might be linear. If it's not linear, I can't really do the equation. From 99 to 139, I'm going to do 139 take away 99, and I get 40. So I went up 40. And then 179 take away 139 is 40. And then 219 take away 179, also 40. All right, on the x side, these differences are my change in x or delta x. And on the y side, these are the differences in the y values or delta y. So my delta y is 40, and my delta x is 4. 40 divided by 4 is 10. I don't have any units to use because it was just x and y. So all this tells me is that every 1 I move up on the x side, we're going to go up by 10 on the y side. All right, so we've got the rate of change. Now I need the initial value. So in our previous lesson, we said that to find the initial value, if it's not given in the table, you find the point that is closest to your initial value, which would be this one. And I'm going to start with 99. When we were moving down the table, we were adding 10 every time. So if I'm going backwards up the table, I would subtract 10 every time. And how many times am I going to subtract 10? 6 times, right? So I need to move back 6 spots in the table to get to term 0. So I'm going to do that 6 times, right? I didn't use the 40, right? Because the 40 was for every 4 values. I want to know how much it is for every 1 that we're moving down. So every time we go 1 space in x, we're going up 10 on the y, right? So I want to use the rate of change, not the 40. That's the difference. All right, so 99, I would multiply first. So 10 times 6 is 60. And then 99 take away 60 is 39. Right, so we're going back 10 every time, and we're doing it 6 times to get back to 0 because we're currently at 6. All right, so my equation should be y equals my initial value, so 39, and then we're adding 10, and we're doing it x amount of times, right? And then that equation would allow me to calculate any value I wanted in that table without having to show too much work. Okay, we have one more example, and my computer screen has frozen, so I'm not entirely sure that this is working, but fingers crossed it is. Just pausing to see if it comes back. There we go. All right, hopefully it didn't do anything too weird. All right, so I've got X and Y. So we're going to do the same thing as last time. First, look, is the initial value in the table? No, I don't have a term 0. That's unfortunate. So rate of change. How do we calculate rate of change? Delta Y over delta X. Right? Delta Y and delta X are the change in Y and the change in X. So I need to calculate my differences to get the change. So from 100 to 120, I went up 20. From 120 to 140, I went up 20. From 140 to 160, I went up 20. On the other side, from 350 to 310, I subtracted 40. You can do 310 take away 350, but I can do this one in my head. All right, 310 to 270, I went down 40 again. And from 270 to 230, I went down another 40. All right, this side is X. These are my change in X or delta X. This side is Y, so this is the change in Y or delta Y. So when I do delta Y over delta X, we are going to get negative 40 divided by 20. Negative 40 divided by 20 is negative 2. And there are no units here, so it's just negative 2. What this means is that for every 1 we're going up on the X side, we are going down 2 on the Y side. All right, initial value. We said it wasn't in the table. I want to find the closest I can get, which is here, 100 and 350. So we're going to start at 350. And then the regular rate of change says we are going down 2 every time. So if I want to go backwards, I'm going to have to add 2. And we're going to do it 100 times to get back to 0. All right, I'm going to use my order of operations and multiply before we add. 2 times 100 is 200. And then 350 plus 200 is 550. So the term 0, or my initial value, is 550. So my equation is going to be y equals my starting value, so 550. And then we are subtracting 2 every time. So we're subtracting 2, and we're doing it x times. Right? So that equation would be good if I wanted to find term 1000, right? I could just plug in 1000 for x and then calculate. All right, so there are practice questions for you to do. Anything you do not finish during class today is going to be homework. So be productive and get that done. All right, have a great rest of your day.